Right, so the topic that we look at next is cognitive development in middle childhood, which is between the years of around 6 to 12, right? And when we consider cognitive development, one of the first theories that we look at is that of Piaget. Now, according to Piaget, children of this age have entered what he calls the concrete operation stage. And according to Piaget, children at this age are much more logical than they were earlier, right? You can see this through a number of illustrations. For example, when you ask, let's suppose, an 8-year-old the same sort of conservation task that was explained earlier as well, in the sense that, you have a tall glass of water, right? And then you have a shorter but wider glass of water, right? And you pour this water into this glass and you ask the children, which glass has more water, right? So this is basically the conservation task that we had, right? Now, what happens is that at 8 years, children are able to pass this task. So they're able to say that it's the same amount of water, that it doesn't matter if it's poured from a tall container, right, into a short container, right? And 8-year-olds will basically tell the experimenter that, if you pour the water back, it is going to be the same amount of water. So they will not be confused by the different heights, right? That's because they have also, mastered reversibility of thought, right? That's something that we went over previously as well, in the sense that they're able to understand that, they're able to reverse their thought from looking just at height, right? And thinking about this, that, this water, before it was poured into this container, right? If we go back, we see that when it was in this container, it was a particular height, but it's the same amount of water. No water is lost, right? So their thought has attained reversibility. It is not, sort of centered only on one aspect of the problem anymore, right? So children who are at the concrete operational stage, right, what we say is that they have mastered, right? They have developed the ability to pass Piaget's conservation task. So similarly, when we say, that children are able to successfully accomplish the conservation task, and that they're also able to reverse thought, which is that, they're able to sort of follow through a series of steps in solving a particular problem and then reverse direction and come to the very beginning. An example of this is that, when they have the conservation task, so they're able to look at the starting point, in the sense that they're able to see the series that, water was poured from a tall glass onto a smaller yet a wider glass, and they're able to sort of reverse direction and come back to the starting point, in the sense that, this water, it was never lost and it has to be the same amount of water, right? So that is what basically reversibility is about. Similarly, when we're talking about cognitive attainments, another thing that young children are able to accomplish is that they are able to pass Piaget's class inclusion task. Now, I hope you guys remember what that was. If not, I'll just show you. This is the class inclusion task, in which there are 4 blue flowers and there are, I think, around 12 yellow flowers. And if you ask children, are there more yellow flowers or flowers? So children will always answer that there are more yellow flowers. Now, that is obviously because children are not able to, Piaget again says, reverse thought, in the sense that they are so taken by the fact that there are more yellow flowers than blue flowers that they're not able to classify properly, because all of these are flowers, right? Yellow flowers are a subcategory of flowers in general, right? But children who are in the concrete operational stage are able to pass this class inclusion task or this class inclusion test. They are able to correctly say that there are more flowers, right? So children of this age are able to differentiate between general categories and subcategories that exist within these more general categories, right? So that is something that children are getting better at. A reason for this could be that children of this age are sort of accumulating a variety of different objects. So for example, they might have a lot of Pokemon cards, right? And they're always sorting through these Pokemon cards based on different figures, based on different characters, based on a variety of different classifications. So as children work with and play around with classifications, they get better at understanding that there are general categories and that subcategories exist within these more general categories, right? So that is another accomplishment that comes with middle childhood. Have other accomplishments such as that of seriation. Now, what exactly is seriation? It is basically ordering a number of different objects on the basis of a particular characteristic. So, for example, you might have, a lot of different objects that are different in height, right? Now, if I were to jumble these up, right, if I were to basically make them such, right? And if I asked a child who is in this particular age range, right, to, you know, to sort them in order, right? So what a child will do is that they will be able to sort them and make them look like this in terms of, there are in terms of ascending height, right? So children this age are able to seriate. They are able to see that, this is the smallest, right? Or this is the smallest here. So this will go first. This seems to be, these actually seem to be the same height. So let me take the height of this one slightly, right? So, this one will probably be the second, then this would be the third, and then the fourth and the fifth, right? So children are able to seriate. They are able to, place different items in such a way that they are, in certain positions according to particular characteristics. So, all of these different sticks, if they are that, are in a particular position because they have certain characteristics. So, for example, this one is the shortest. That is the characteristic of this particular object. This one is longer than this one, but it's shorter than this one, right? Sorry, it's shorter than this one, but it's longer than this one. So therefore, it is in the middle of these two. One of the things that you do see is that children who are around 6 to 7 years of age, they're able to do this in a very planned manner. So, for example, if you ask them to do this task, they'll pick out the smallest one first, and then they'll, if you give them these sticks, let's suppose these are sticks, and you say to them that you give them these sticks, right? And you say to them that you need to seriate them, you need to put them in order of increasing height, increasing length. So they will seriate them like this, but they will start off with a plan. So they'll start off with the smallest one and then move forward. So that does show that there is significant cognitive development, because when you give this task to younger children, they're not able to approach it in a very planned manner. They do it haphazardly. They compare each and every stick. So older children are able to get this right. Then you also have something that Piaget calls transitive inference. Now, what exactly is transitive inference? So in the transitive inference task, what Piaget does is that he shows children three different sticks, right? He shows them to the children in pairs. So the first pair is that of stick A and stick B, right? So let's suppose this is stick A, right? And this is stick B, right? Now the next pairing is stick B, right? Which is the same stick that we had here. Let's just start over. I think I made this stick slightly less fat, right? So this is stick B, which is the same stick that we had in the previous pair. And now we have another stick, which is stick C, right? Now, when you ask children which is the longest stick, right, what they need to do is that they need to consider three kinds of relationships, right? Which is the A-B relationship, the B-C relationship, and then the A-C relationship as well, right? And they've never seen A and C together, right? So they need to make an inference about the, sort of relative size of A and C. And they need to make an inference here. The inference that they need to make is that, A is larger than B, right? And B is larger than C. Hence, right, A must be larger than C. So this is basically an inference that they're making, right? So this is extremely important. And this is, really a huge leap in terms of logical thought, right? And also in inference making, right? So what you see is that children are able to pass this task. However, one thing that you find is that, they're able to pass this task with, the sticks that are shown to them, right? Which are concrete objects, right? However, if you are to make this more abstract, right? And to say that, if, for example, Sally is taller than Tom, and Tom, sorry, and Tom is taller than Harry. So who is the tallest? Now, this is the same logic that you have here, but interestingly, children who are in the concrete operation stage are not able to understand this because this is very hypothetical. And that is why you have the name here, which is that, it's the concrete operation stage, right? That's the name that you have here, that it's not really, you're not really working with abstract or hypothetical scenarios when you're at this stage. Rather, you're working with very, very concrete objects that are in front of you, just as, for example, these sticks, right? Then obviously you have something that Piaget calls cognitive maps, which is basically, the mental representation that you're making of the environment around you. And what you see usually is that cognitive maps are becoming more complex, right? They are also beginning to include more landmarks with children as they get older. So when you're checking for a cognitive map, you might ask a child to create a map of their classroom or their neighborhood, right? And you look at the complexity of that particular map. However, one of the things that you see is that map making is something that is very, very influenced by the sort of culture that you live in, right? It's something that's mediated by the sort of culture that, one belongs to. And you see an example of this. So, for example, here you have, in this picture, you have a map drawn by an Indian child, right, of their neighborhood. And this is the map of a child in the United States. Now, the child in the United States has all of these marked lanes and all of these different, streets, and the directions are there, but there are not a lot of people and there are not a lot of landmarks. Here, there are a lot of social activities that are at play. You see that, if you were to zoom into this picture, right, one of the things that you see is that, you have, for example, different cars here. You have different people who are indulging in different kinds of activities, right? So here there are people who are, here you have people who are, what do they seem to be doing? They seem to be waiting for a bus. But over here, you seem to have these people who are just, standing by. Then you have here someone who's riding a motorcycle right here, right? So there are a lot of different social activities that are at play here as well. And that's very interesting to see that, different cultures have these different styles of map making. One of the things that you see is that it's not by later middle childhood, so not till children are around, 8 to, sorry about this, 8 to 10 years that you begin to see that they're able to see, able to take this larger view of the space that they're wanting to draw out, right? So that's another thing with map making. Usually, younger children in middle childhood, right? Around 6 years old, let's suppose, they will usually try to draw a map through an organized route of travel. So if you ask them, what does your neighborhood look like, right? So usually it will be centered around, what their route of travel looks like. So children, obviously, map making and cognitive maps, what they do also, look at is perspective taking, because map making does require a significant amount of perspective taking. So this is basically, everything about the concrete operational stage. And the limitation, we've already gone over it, is that, thought in this stage is not abstract at all. Rather, it's just, grounded in things that are very, very concrete or right in front of the child. Right. Next, what we get to are some of the information processing perspectives. Now, what the information processing perspectives bring to the table are looking at cognitive development in terms of, these separate sort of domains working together, right? The information processing perspective sort of talks about how, firstly, perceptual speed and capacity is increasing, and that is basically laying the groundwork for all sorts of cognitive development that we see. So if children are able to sort of, you know, um, perceive a particular problem quickly or perceive various parts of the problem more quickly, what is happening is that they're able to solve that particular problem in a better fashion. If they're able to sort of incorporate different aspects of that problem better, so then obviously they're able to look at these different aspects. One of the things that you see is that, capacity, short-term memory capacity, does increase during this stage, and it goes from around 4 objects to something like 7 objects, right, in middle childhood. So, perceptual capacity, you can obviously see that increasing when you, look at this development. Perceptual speed is also increasing when you look at something like reaction time, and we considered this when we were talking about physical development as well, that, you have the perceptual speed also increasing. So obviously, when you have both of these aspects, sort of increasing, what that will do is that will, free up space in working memory so that you can get at different aspects of the problem and look at all of them and sort of, begin solving the problem from that point. Then information processing perspectives also lay a lot of emphasis on how there are gains in inhibition. Now, what that means is that you are basically able to inhibit an unfavorable response for a more favorable response. So, for example, information processing perspective, basically the way that they looked at this conservation task was that, by saying that children are not able to inhibit the first response that they have, which is to say that, this glass has more water, right? But as they're able to inhibit their responses, the unfavorable responses better, as they are, reaching middle childhood, so that is what is basically letting them solve these problems and give correct answers to, problems such as the conservation problem put forth by Piaget. So that is another sort of aspect of, that is put forth by the information processing perspective. Other things that are changing, which are relevant, are also something like attention. So, one of the things that you see is that children are better able to attend to the important features of a problem and sort of block out all of the irrelevant features. So, researchers test for this by, contaminating a problem by introducing irrelevant features. But what they do see is that children are better able to focus during middle childhood, and that might be one of the reasons that they are able to become better problem solvers, or they become able to become more logical in their thinking. Then obviously there's also gains in memory. So what we see with regards to memory is that children are able to use different strategies for memorizing, and these strategies are becoming more and more complex. So let's suppose they're able to rehearse information in order to hold it, right? They're also able to categorize different sorts of information. So for example, if they're trying to, for example, learn the name of a particular city, they might categorize all of the different cities in that particular province together. So they're becoming better at categorizing. Then they're also becoming better at this other memory strategy, which is called elaboration. Now let's suppose you have to remember the words for any sort of test that you have at school, which are something like fish and pipe. So elaboration basically requires that you build some sort of relationship between these words. So, you, for example, you imagine the fish smoking a pipe. Now, that imagery is bound to make you remember these two words. So, this is the strategy of elaboration. And what you see is that children are also aware of the strategies that they're using, and that awareness really helps them, use these strategies more efficiently. Another thing that is sort of, on the rise is what we call self-regulation. So children, and this is sort of related to children's theory of mind, in the sense that children are able to self-regulate in terms of, when specifically when they're looking at classroom learning, they're able to evaluate how well their learning is going. And children, sort of gain the skills steadily. So, for example, younger children might, be aware that if they reread a particular paragraph, that's really going to help them understand that paragraph better, but they might not be able to implement that strategy. They might not be able to make themselves reread that paragraph. But as you get older, what you see is that children become better at self-regulating their own learning, right? And they become more familiar with different strategies that work for them in terms of learning, right? So that is something that's also very, very important, that, children are beginning to self-regulate, and they're able to sort of evaluate their own learning and their own strategies when it comes to something like even memorizing. And this definitely sort of ties in with young children's theory of mind. So, for example, children who are, in the period of middle childhood, they are better able to understand that if you pay attention, you're going to remember a particular phenomena better. So, they know that attention helps in remembering, right? And, so this is one thing, but sort of implementing it goes towards your cognitive self-regulation, right? So yes, so children are, according to the information processing school as well, this is slightly different from how Piaget sort of looks at cognitive development, but, looking at how all of these different areas are developing in terms of what's happening in terms of attention, that you're able to focus better, And with that, you're able to block irrelevant information out, and that you're able to use you know memory strategies more efficiently. You're able to self-regulate. This process is called cognitive self-regulation much better. You're able to evaluate how well your own learning is going and what sort of strategies are going to help you. You have a more refined theory of mind. For example, that paying attention is going to help you remember better. And it's important that if you wish to succeed, you don't get distracted from whatever your goal is at that point, right? They understand that memory helps with understanding, and that you can gain better understanding if you have a wider knowledge base. So all of these things are sort of slowly adding um, themselves onto the young child who is within this age range of 6 to 12 years. So yeah, so this is basically it about cognitive development.